Hi all, this is Shweta Reddy, working as Assistant Professor in the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. So today in Transmission Lines and Waveguides, we are going to see a topic called Input Impedance of the Dissipationless Line. So let's move into the topic. So coming to input impedance of the dissipationless line, normally the input impedance formula is ZS is equal to Vs by Is. And these two equations Vs and Is, from where I have taken this equation is, in the previous video we have seen about voltage and current on the dissipationless line. From in that topic I have derived the fifth and sixth equation. So that fifth and sixth equation I am taking it directly and writing here these two equations, the as Vs is equal to Vr cos beta x plus j Ir R naught sin beta x, and Is is equal to Ir cos beta x plus j Vr by R naught sin beta x. From there I have taken the equations, and after that we know that Zs is equal to Vs by Is, that is input impedance is equal to Vs by Is. So I have Vs, I have Is. I'm going to divide these two equations. And after that, we know the formula VR is equal to IRZR. So in this equation, wherever I have VR, I'm going to replace it by IRZR. So here I have VR, and after that, here I have VR. So wherever I have VR, I'm going to replace it by IR and ZR. So I have rewritten the equation. And after that, what I'm going to do here is, can you see I am taking IR as common. I have IR here and also I have IR here. I'm going to take IR as common and writing the numerator alone. And similarly, I have IR here and IR here and taking IR common in the denominator also and writing the denominator alone. So after that, what I'm doing here is I'm cancelling the IR which is in the numerator as well as in denominator and rewriting the equation again like this. After that, can you see R naught here? Yes, this R naught, I'm going to take LCM. So if I take LCM, what will happen? I'm writing the numerator as it is, and denominator, what I'm doing, I'm going to take this R naught to this cos beta x also. So R naught cos beta x and plus j ZR sin beta x and the whole divide by R naught. This is how I got this equation. Now can I take this R naught to the numerator? So if I take R naught to the numerator, R naught will be kept outside the bracket, and after that the remaining terms I'm going to write as it is. So from the previous equation, if I take cos beta x common, this equation can be rewritten as, that is R naught cos beta x I'm taking common. So ZR plus J R naught. Here I had sin beta x alone. So I am dividing this cos beta x, and similarly in the denominator also I am doing the same. Now can I cancel this cos beta x and cos beta x and writing the equation, and also we know that sin beta x by cos beta x is equal to tan beta x, since sin by cos is tan, and here also I am replacing sin by cos as tan. This is how I got the first equation. Now we will see the input impedance of open and short circuit lines. First we will solve for short circuit lines and then go for open circuit lines. So for short circuit line, the condition is ZR is equal to 0. So wherever I have ZR, I'm going to replace as 0 from the first equation. So I'm rewriting the first equation again, and after that wherever I have ZR, I'm going to replace 0. So here I have ZR and here also I have ZR, so I'm going to replace it as 0. So balance terms will be R naught J R naught tan beta x by R naught. So I'll be cancelling this R naught and R naught, and ZSC will be, final equation will be J R naught tan beta x. This is how I got this ZSC, and we also know that beta is equal to 2 pi by lambda. So I'm going to replace this beta as 2 pi by lambda. So the final ZSC equation is J R naught tan 2 pi by 2 pi x by lambda. So this is ZSC. So I'm going to replace this Z dash as ZSC since it is a short circuit line. Now coming for open circuit line, the condition is ZR is equal to infinity. So I'm going to write this first equation again, and if I substitute ZR as infinity directly, the whole equation will become infinity. So what I'm going to do here is, so what I said, if I substitute ZR as 0, the whole equation will become infinity. So in order to avoid that, what we are going to do here is I'm going to take ZR common. So if I take ZR common, I'll be getting ZR 1 plus J R naught by ZR tan beta x, and similarly in the denominator also I'm going to take ZR common, so R naught by ZR plus J tan beta x. This is how I got this equation. And after that, what I'm going to do here is I'm going to cancel this ZR and ZR term. So the remaining equation will be, I'm going to write this R naught similar, and also this part will be the same. Only ZR and ZR terms will be getting cancelled. So as I said earlier, for open circuit line, ZR will be infinity. Now if I substitute wherever, if I have ZR, I'm going to replace it by infinity. So what will happen? Actually here it is ZR, not Z naught. So what is 1 by infinity? 1 by infinity is nothing but 0. So wherever I have divide by ZR means 1 by infinity. 1 by infinity means 0. So this whole term becomes 0. And here also the whole term becomes 0 because 1 by infinity is nothing but 0. So the ZOC means open circuit. So ZOC will be R naught 1 plus 0 by 0 plus J tan beta x. So the final equation will be R naught 1 by J tan beta x. So what is 1 by tan? This 1 by tan. What is 1 by tan? 1 by tan is nothing but cot. So cot beta x, and I am writing this R naught as same which is in the previous equation. And after that, what is 1 by j? 1 by j I can write it as minus j. So this equation ZOC is equal to minus j R naught cot beta x. So what I got for ZSC, I got ZSC is equal to J R naught tan beta x, and what I got for ZOC minus J R naught cot beta x. Now I'm going to multiply this ZSC and ZOC. So if I multiply ZSC and ZOC, ZSC into ZOC is equal to J R naught tan beta x minus J R naught cot beta x. So what will happen? Can I write cot as 1 by tan? So if I write 1 by tan here, can I cancel this tan beta x and 1 by tan beta x? So what will be the remaining term? Minus j square r naught square. So what is the value for minus j square? Normally j square value is minus 1. So minus 1 into minus 1 means what will happen? It will become 1. So ZSC into ZOC is nothing but R naught square, or else I can write R naught is equal to root of ZSC into ZOC. I hope this is clear. Thank you all.